Usually in the treatment of a leukemia, we use chemotherapy or drugs, which wipes out every immune cells and then kind of like a restart. Sometimes it is not the best way to do because there are some leukemia cells that are left in the patient, and along the year, these immune cells grows again and it leads the patient to relapse. So usually leukemia is happen in the immune cells. So immune cells start from the origin cells and then it develops. And there is a process of development which involve a lot of factors to become a fully functional immune cells. These factors sometimes they are crucial, they are important for the development. If they are missing, it leads the cells towards something that we don't want, such as cancer cell or leukemia cells. So in my case, I'm specifically interested in the oncogenes which is called PTEN. So we found that 1/3 of the leukemia patient has a mutation in this gene PTEN. My subject of the thesis is to try to make a mathematical model of how cells without PTEN choosing its fate, if it's going to be normal or if it's going to be cancer, and how PTEN is involved in this. From the dataset, the tools that I'll be using is called single-cell RNA sequencing. What single-cell RNA sequencing does is kind of like this metaphor. So you are in the forest, you fly up, and then you take a picture of the whole forest. And there are multiple elephants. And you capture the picture of elephants, and you try to rearrange it according to the similarity of these pictures. Now you see that there's also elephant with 2 trunks. And the elephant with 2 trunks are in a similar size with the teenager one. So you can see that from the teenager, you can split 2 elephant with 2 trunks. So my experimental approach is first to start with building a mathematical model, which is specifically called a logical model. If you have 1 node, 2 node, and this 2 node activates a node 3, like an electrical circuit. At the same time, we'll use a mouse model with PTEN deleted and get the dataset and use that dataset to refine the mathematical model. Once the model is refined and precise, we'll use this model to understand the role of PTEN into how it makes a leukemia. This is the data set of single cells that we got from the mice. At some point, they will have the crossroad to decide whether it will become a tumor or it will become a normal cells. The tumor are right here, and the normal cells are right here. Currently, my PhD is to understand how cells makes a decision, but it's only one cells. My next step would be to kind of understand how when the cells are together in a layer or in an organs, how it decides. For example, you have an embryo, how it decides that this part are going to become head or this part is going to become tails, also using a mathematical model.